Okay, so let's do practice exam 2A. I'm going to do this set of questions together since they all relate to this big prompt. Okay, so it says the following 5 questions are based on this information and they give you all this information. The first thing I think you should do when you start off with these problems is write out everything that they give you. So here they're giving you an average age of X bar. So they're giving you average age X bar of 27.5. So what I'm going to do here is I'm going to write X bar equals 27.5. You can see that they also give us a population standard deviation of 2.3 and population standard deviation. The fact that we have population is important. That's something we need to pay attention to when doing these problems. Do we have population standard deviation or sample standard deviation? So here we have population. So I'm just going to do pop standard deviation. Okay, that means population standard deviation. And that is 2.3. Okay, is there anything else that's given to us? Yes, right here it says we have a random sample of 18. So I'm just going to put that right here. We have an N of 18. And we want to construct a 9. So this is the problem. Construct a 99% confidence interval. This means this is a chapter 8 problem because in chapter 8, that's where we did interval estimates. So I have that cheat sheet pulled up as well. So we can take a look at this when we get to it. I just want to make sure that you guys also have your cheat sheets available because this really helps you with doing the problems. Okay, and we need our alpha, right? And how do we get our alpha? That's going to be 1 minus our confidence interval. So we're going to have an alpha of 0.01. Okay. So whenever we do our confidence intervals, so like I said, we have to pay attention to whether we have population standard deviation or sample standard deviation. And in this problem, you can see that we have population standard deviation. And that means we are going to be using this top case right here, right? So we have 3 different cases. That's what I like to call it. We have a population standard deviation is known case. We have population standard deviation is not known case. And we have a proportions case. But we're going to do this one because this is what we have. We have population standard deviation. So what are the values that we need to get our interval estimate? So we need our X bar value, which is also our point estimate. We need our critical value, and we need our standard error. Okay, so the great thing about these set of questions is it guides you through getting the answer. So we said that we need our critical value and our standard error. So that's what the first 2 questions are asking for, critical value and standard error. All right, so let's get started. How do we get our standard error? If you guys pull up the cheat sheet, you're going to see that's standard deviation. So standard deviation divided by your square root of n. So in this case, that's going to be your 2.3 divided by square root of 18. And if you were to put this in Excel, you're going to get 0.54. So that answer matches up with this one. So there we go. That's our answer. Okay. So the next question is asking for the critical value. So the important thing here is to note that we have population standard deviation, right? So because we have population standard deviation, the critical value is solved by z of alpha divided by 2. And what is z of alpha divided by 2? That is norm dot s dot inverse 1 minus alpha divided by 2. So let's do that. We're going to put this in Excel equals norm dot s dot inverse 1 minus, what's our alpha? So we wrote that right here. Our alpha is 0.01. So 0.01 divided by 2. Alrighty. And whenever you put this function into Excel, you are going to get 2.5758, which is approximately 2.58. So the answer here is going to be C. Okay, so now we are looking to get the confidence interval estimate. We have this value right here, which is you're going to be adding and subtracting to get your upper and lower limits to this other value. So what is this value right here? If we look at our cheat sheet, let's go back to this. We see that this value that's being added and subtracted is your X bar value. So our X bar value here is 27.5. Okay, so I'm just going to write that 27.5. And then we're going to do plus or minus. And then what? It's going to be our margin of error, right? But how do we get our margin of error? So all we have is our critical value and our standard error. That's what we just calculated. So to get margin of error, we have to multiply the two, critical value times standard error. So we're looking at this one, critical value times standard error, same formula, but okay, yeah. Critical value times standard error. So here, what's our critical value? We said our critical value is 2.58, and we said our standard error is right here is 0.54, right? And once we multiply those two together, we are going to get 1.396. So this answer is going to match up with D. So there we go. Now, number 4 is saying that a company claims that the average age of drivers is 26.9. In light of the sample evidence and the 1% level of significance, is our claim statistically justified or is it not? So what this is asking is this value in between this range, right? Because we're subtracting 1.396 and we're adding 1.396. So what we need to do is we would go on Excel, right? And we would actually solve this out. So what you're going to do is take your X bar and you're going to subtract 1.396 and you're going to do 27.5 X bar plus 1.396. And when you do that, you're going to get around, let's say 28.896. And actually this is, okay, this is going to be your upper limit, 28.896. And your lower limit is going to be 26.103. Okay. So is this value 26.9 in between this range? And the answer is yes, right? 26.9 is within this range. So then we can say your claim is statistically justified. So the answer would be A. The next question is saying if we decrease our confidence level from 0.99 to 0.95, so from 99% to 95%, what would happen to our margin of error? So let's figure this out. how do we calculate our margin of error? That's going to be our critical value times our standard of error. Our standard of error is not going to change. So our standard of error is still going to be 0.54. What's going to change is our critical value, because this is the confidence level affects the critical value. So if you guys remember the formula for critical value, it is, just make sure you can see this. Okay, so it is norm dot s dot inverse 1 minus alpha divided by 2. So our alpha has changed. It is no longer 0.01. Our alpha is now 0.05. Okay. And we get this by doing 1 minus 0.99 and 1 minus 0.95. So this was what the problem was originally, and this is what we're changing it to. So that just means we need to plug in this. Into Excel. And when we do that, we're going to get a critical value of 1.95 996, and it goes on. Okay, and then this is what we need to put into here, right? Because we need to multiply the critical value by the standard of error to get the margin of error. So 1. Let's say 96, just going to round that. And whenever you multiply these on Excel, so I'm rounding just so you guys know. So this may not be exactly it. When I put this in on Excel, I use cell referencing. So I use the full number that was in Excel. But anyways, the number that you're going to get for your margin of error will be 1.0625. Okay. So what just happened to our margin of error? Our margin of error went from here, it's the margin of error we had before, it went from 1.3 to 1.06. So it went down, right? So we're just going to say it has decreased. Just so that you can see that. Okay.